Yes, it's another good day. This is 300 plus academy where all we do is exams, tutoring. Okay, let's quickly take a dive into the world of chemistry. What we'll be looking today is introduction to chemistry and what we call scientific method. Being that chemistry is an investigative science, therefore we must talk of scientific method. So very quickly, let's get right into it. Okay, when we talk about chemistry, chemistry is a branch of pure science. It deals with the study of materials. Let's get it right. When we talk about pure science, the other two being physics and biology. So chemistry, it's one of the branches of pure science. And what it does is that it study materials. It's from the word materials we brought out the word matter. So what chemistry does is to study anything, just about anything you see around you. So long as you can feel it, you can touch it, it's a material, it's a matter. So what chemistry does is to study materials. And when you say chemistry study materials, what is it? How does chemistry study materials? What chemistry does is that it asks the right set of questions. I said, like you can see on the board, chemistry investigates or probes into the composition. Take for instance, if I have this material, I'm picking this from my table here. If I have this material, as far as chemistry is concerned, this is a material. It is just about anything. What I want to investigate or probe is one, the composition of this material. What and what is this composed of? What and what is this made up of? That is what chemistry wants to do. It wants to look at the properties of material. For example, if I drop this in water, does it dissolve? Does it float? If I try to burn this, does it react with oxygen? Of course, when you talk about combustion or burning, it simply means a material or matter reacting with oxygen. Does this burn in air? If I add an acid to this, is any gas evolved? Those are the questions I want to ask. So when you talk about chemistry, it investigates or probes into the composition. One, two, it looks at the properties that materials or matter exhibit, and also it looks at the uses. What can we use that material or matter for? What can we produce with that material? Those are the things that chemistry look at. It looks at composition, properties, and uses of materials. It also investigates the changes that materials can undergo when subjected to certain conditions. Take, for example, if I have water, water is a liquid normally, but if I subject it to very low temperature, then it changes to ice, which is a solid state. So what chemistry does is that it wants to look at the changes that can happen to material. So just about four things. When you say chemistry is the study of material, you ask yourself, how do we want to study material? We want to study materials in chemistry by first looking at the composition of that materials. We want to look at the properties of that materials. We want to look at what we can use that material for the uses. And we want to investigate the changes that can happen to that material. Also, since chemistry is more or less investigating and probing, it wants to look at what and what is this made up of. What can it's always investigating and probing, trying or seeking to know more about any material that we encounter. Then we can therefore say chemistry is an investigative science. It's a science that seeks to investigate, and therefore we talk about scientific method because in science there are actually actionable steps which we call scientific method that we follow in order to arrive at giving answers to everything that concerns matter, and not just about chemistry alone, even in biology, which deals with the study of life. You want to investigate life there, so you talk about scientific method. If you talk about physics, you want to look at matter and energy. Of course, in physics, you want to create, that's more of a creational science. You want to assemble matter. And when you assemble matter, you want to look at how you can convert energy from one form to another. So that's more or less like looking at the relationship between matter and energy. You still talk about scientific method there. So generally in science, not just about chemistry alone, we investigate and therefore we talk about scientific method. Now, talking about scientific method, it is a method we use in sciences to research. Like you can see on the board, it is a method of research in which a problem is identified. We identify problem, and relevant data or info are gathered. Hypothesis. Yes, hypothesis is singular. Hypothesis is singular. Hypothesis is a plural, are formulated from this data, and the hypotheses are tested. Let me dwell more on that. When you talk about scientific method, we basically want to research because we must have observed a certain problem, or we must have observed a certain phenomenon. Okay, let's take for example, let me demonstrate that here. Let's assume suddenly everywhere is dark. See, everywhere is dark right about now. So the question I'm going to begin to ask myself is this: why is everywhere dark? Am I out of electricity unit? Am I out of electricity unit? I'll ask myself, am I out of electricity unit? Is it that the bulb is burned out? So what I'm doing there is that I observe that everywhere suddenly goes dark. And then I begin to ask myself, look at it. It is a method of research in which a problem is identified. I'd identified a problem there. Now I am trying to gather data or info so that I can have what I call hypothesis. In some cases, we see a pattern. Okay, I identified a problem. Now everywhere goes dark. It doesn't make sense for me to say everywhere is dark because I'm holding this. It must be because of this whiteboard marker. That is not intelligent. But if I put forward something reasonable like, oh, everywhere was dark simply because I was out of electricity unit, or perhaps the bulb burned out, those ones are intelligent. So intelligent explanation is what we call hypothesis. Intelligent guess, tentative explanation, that is what an hypothesis is. So in scientific method, we basically, see a problem, we observe stuff, and then we try to give a reasonable explanation to what we've observed. So giving reasonable explanation to what you've observed is what we call hypothesis. Now your explanation can be more than one, so therefore you talk about hypothesis. I can now move forward now and test my hypothesis. How do I test my hypothesis? I could check the other room. If I check the other room, if I try to switch on the light there, and the bulb working, then that strikes out my earlier hypothesis where I said that perhaps my bulb burned out. So you can see, so after putting forward hypothesis, then I have to experiment, I have to test my hypothesis. Then I can as well move forward to check my electricity units to see, oh, do I still have electricity unit? In a case where I do not have electricity unit, I can now say, okay, the reason why everywhere suddenly is gone dark is because I'm out of electricity unit. But think of this situation: if I check and I found out that I still have electricity unit, then it means my first two hypotheses were wrong. Then I need to think again and formulate more hypotheses. You only move forward from the stage of hypothesis when you get a positive result after experimenting. If you get a negative result after experimenting, then you have to go back to formulate another set of hypothesis. Hypothesis in this case means intelligent guess. It means tentative explanation. You cannot give unintelligent guess, absurd guess, and call that an hypothesis. Imagine someone telling me, oh, the reason why this room is dark is because I wrote the topic for today in blue marker. That is not related to what we are saying at all. That is not in any way intelligent. When we talk about hypothesis, yes, we want to guess, we want to give reasons for something, but it has to be intelligent guesses or reasoning. So moving on, scientific method is a general approach to problems that involves making observations. You must have observed something, then you seek patterns in the observation, then you formulate hypotheses to explain what you've observed. And then you test these hypotheses by further experiments. Those hypotheses that withstand such tests, that's come out with positive results and proven themselves useful in explaining and predicting what we've observed or behavior, are what we now know is what is now known as a theory. In other words, theories. So look at it again. You observe something. When you observe something, you try to look for a pattern. And how do you get a pattern? By gathering data or info. Now, once you've done that, you then test your, you then formulate or put forward hypothesis or intelligent guess. Once you've done that, you test your hypothesis. If you get a positive result, then your hypothesis becomes a theory. If you get a negative result, you go back to formulate another set of hypotheses. To put things into a more proper perspective, using a diagrammatic expression, when we talk about scientific process, it usually starts with observation. Like in the last example, we observed that everywhere suddenly goes dark. So that's an observation. In some cases, it may be questions. In some cases, it may be based on purpose. What can we do? How can we solve this problem? It will be observations. But once you observe something, a process or what have you, there usually has to be a pattern, and that usually comes when you ask the right question. Like in that example, everywhere was dark, and then I started to ask myself, why is everywhere dark? That's the right question. Then after that, after asking questions, I then should be able to hypothesize. That I should be able to put forward hypothesis. In plural form, it means hypothesis, because the reason to explain my observation might be more than one. Like in that example, I put forward hypothesis that, look, everywhere goes dark simply because the bulb was burned out, or amount of electricity units. So those are the two hypotheses I put forward, and they are intelligent. It's going to be wrong or foolish or stupid, what have you, for me to say everywhere is dark simply because this board is white, or everywhere is dark simply because of this marker. You understand? That's not an intelligent explanation. So once you observe, you see a pattern. Once you see a pattern, you have to put forward reasonable or tentative explanation to your observation. That's why we say hypothesis is an educated guess, a prediction, or an intelligent guess. Or we say a tentative explanation. You bring forward those intelligent guesses to try to explain your observation. Then the next thing you do is to now test or experiment your. So I haven't put forward hypothesis. Two hypotheses. I had to check, and I did that was I went to the other room, put on the switch. The light didn't come on as well. Then I left that because I didn't get any result from that really. I left that. I had to check and found out that, look, I was out of electricity unit, and that tells me that, look, I got a positive result there, and I can now put it forward that, look, everywhere was dark simply because I was out of electricity units. In the field of science, Once hypotheses have been put forward and have been experimented and a positive result obtained, then it becomes a theory or a model. A theory or a model is a simple or complex explanation put forward by scientists to explain various phenomena. You're putting forward an explanation because you've tested that explanation. That's your hypothesis. You've tested it and you found it to be true. It has given you positive results. So you are now using that to explain what you have observed. So a theory or model is a simple or complex explanation put forward by scientists to explain observations or various phenomenon. Of course, if you get a negative result, let's imagine that in that my little experiment, I checked the other room, I put on the switch, the light was not coming on, I checked, I still have electricity unit. That means the first two hypotheses I had put forward was not good enough, so I have to move back because I'm getting negative results. Having experimented, I have to move back to my hypothesis and put forward another hypothesis. Okay, so another hypothesis will be, could it be that we are experiencing a power outage in the whole vicinity, in the whole area that I am? So I need to maybe test that by asking my neighbor in the next compound, okay, do you have power? So if they then tell me no, they don't have power because there is a general power outage, okay, that means I'm getting a positive result and I can only put that down as, okay, it's a fact now. You understand? I have an explanation as to why my room is dark. So it is always that if you put forward a hypothesis, if you get a positive result, it becomes a model. If you get a negative result, you go back to your hypothesis stage and try to produce more intelligent guess. Okay, now when you have a theory or a model in the field of science, it must then be tested via further experiment and via more information and data gathering. And in this further experiment, if the theory or model holds sway, if they give us results that are very, very much sensible within the confines of the field of science, then it becomes scientific law or principle. See, it becomes scientific law or principle. When we say scientific law of principle, it simply means your theory or model, your explanation now has been proven over and over and has stood the test of time. And now we can put that out as a concise statement mathematically. Look at it. Let's take Boyle's law, for example. You say a volume is inversely proportional to pressure. Is a statement of fact that whenever volume of a gas increases, the pressure decreases. If the pressure increases, the volume decreases, provided that the temperature remains constant. Charles's law is another one. So when you talk about scientific law, it simply means my model or my theory or my explanation as to what I had observed has been proven over time to be true within limits of available scientific evidences. So that's why we say a scientific law or principle is a concise statement of what we have observed or a generalized rule to explain our observations, and we can put that in the form of verbal or mathematical statements. That is what that means. Take note of this. Take note of this. I've had someone argue postulates. Well, when you talk about postulates, look at our theory or model. Before we have a theory or model, it must have been proven to be true by experiment. But in the case of a postulate, this is just a statement. Postulates are statements that are accepted as true without being proven, without being experimented. They are built upon knowledge that satisfies the reader. We just generally agree here that this statement makes sense. That's what the postulate is. Takes, for instance, in Dalton's in Dalton's postulate, where he said all matter consists of indivisible particles called atoms. That was then, when they never had access to sophisticated scientific tools. That was when he made that statement. It was not experimented, it was not proven. So we can put that as a postulate. But right now, in the modern world, we have access to sophisticated tools, and we have been able to prove that matter, or as it were, is very much divisible. Yes, you talk about atomic subparticles, proton, neutron, electron, proving to us that look, matter is continuous and we can continue to divide matter infinitely. And aside that, you want to talk about nuclear fission. You said it is indivisible, but via nuclear fission, as we will see later as we continue in this journey of chemistry, under radioactivity, that look, matter is actually divisible. So because we've experimented that now and we found that we can divide matter, unlike when they never experimented. So that's what a postulate is. A postulate is just a statement that has not been proven but that is built on just general knowledge that satisfies the reader. Okay, that is scientific method that explains how we make discoveries, how we make our findings in the field of science. So with this, we will not even need to go through this in biology. We will not need to go through this in physics again, as this is what we need in all of the field of science. And that ends that is introduction to chemistry, where we study matter, we look at the composition, properties, uses, and the changes that material can undergo. And as well, since chemistry is an investigative science, we've been able to move into scientific method and explain the processes involved in making discoveries and putting things right in the field of science. So subsequently, we'll be looking at the real nature of matter, talking about solid, liquid, gas, plasma. We'll be looking at the change of states. We'll be looking at explanations for the various change of states: boiling, condensation, evaporation, how evaporation causes cooling, heat, and our heat curve and cooling curve is something we are going to look. We'll look at properties of matter, intensive and extensive properties. We'll look at chemical and physical changes, and then subsequently we'll move into more concepts and Avogadro's number, and as well would look at stoichiometry as a whole. That's a part you're going to enjoy. But for now, this is where we pause things. So I would implore that you subscribe, share with your peers, and of course, turn on the notification bell so that you are notified at any time that we upload lecture content that will aid you in the course of your exam prep. So for now, from me to you, it's bye.